Hello and good morning everyone. I welcome you all to India's largest e-learning platform Unacademy, and I welcome you all to Gate Conqueror channel. Welcome you all to my series of antennas MCQ series. It's a very important series dear for all those who are preparing for competitive exams including GATE and ESC. Wherever antennas is syllabi, this MCQ series is an exclusive series where we cover all the concepts of antennas. Where we try to cover all the topics of antennas, all the MCQs, which will be useful for GATE, engineering services, and all the other competitive exams. So we are into the part 8 of antennas MCQ series. Ask everyone to join very soon dear. Share the link among the maximum. Ask everyone to join very soon. This is going to be an important class. Before we start the class, let me introduce myself. I am GC Reddy. Having overall 15 years of experience in teaching, guiding and mentoring GATE and ESC aspirants. I work as motivation speaker pan India for the past 12 years, an expert in field theory and communications. Before we move in, let me introduce our Telegram channel for the entire GATE Conqueror team. Official Telegram channel, and this is the link for the same. Just take a screenshot of this after the class. Find some time to join us on Telegram. The benefit of joining us on Telegram is that you get a personal level assistance from all the faculties of the GATE Conqueror channel, including the legendary K.N. Rao sir. So you'll get the complete support for your preparation on a personal level through our Telegram channel. So this is the link for the same dear. And the good news for all the GATE Conqueror followers is that we are increased in number now, and we are targeting to comprehensively finish GATE 2023 and ESC 2023. Now that we are increased in number now, experienced and efficient faculty has joined our channel very soon. In a couple of days, you will be able to see them live on our channel. So the complete team, we are trying to cover GATE 2023 and ESC 2023 for both ECE and electrical. So that's the advantage that you have now. Need not worry. And we are working towards comprehensively covering all the subjects. And in this class also I'll explain how far we had completed EMFT and what are future plans, or how we'll complete the rest of the part of EMFT, and what is the difference between our coverage and other people covering these particular subjects. I'll try to explain in detail the difference in the approach so that you understand the importance of this particular channel. We are into the antennas MCQ series. We are into antennas MCQ series. As you know, antennas is a part of EMFT, and in this particular channel we covered comprehensively complete EMFT. That's our plan. We're marching towards it to comprehensively cover EMFT subject. In EMFT, we'll have 5 modules. Module 1 Elements of EMF Theory. Module 2. Is EM wave propagation. Module 3. So transmission lines. Module 4. Is about waveguides. Module 5 is about antennas and optical fiber communication. Let me start with Module 1. Module 1 is elements of EMF theory. In this module, I had already created a playlist. With 40 videos and 50 hours of class. Exclusive playlist for Module 1. Generally, if you see on any other platform, you won't get information more than 8 to 10 hours, I bet. Maximum. You'll get 8 to 10 hours of information, that too partial. But here, against 8 to 10, 5-fold more information you get. 50 hours of teaching has been done only on Module 1. Good morning, JK. People generally teach complete subject in less than 50 hours. Complete EMFT in less than 50 hours. With all the modules. We covered only Module 1. Elements of EMF theory for 50 hours. You cannot find a better playlist than this. And this is the common syllabus for ECE. It is Module 1. And for electrical, it is complete syllabi. Both ECE and electrical people can prepare for GATE and engineering services, because we covered complete theory concepts, all derivations. I'm telling you, the most important, most difficult derivations we covered, so that we cover up the students who are trying to prepare for engineering services. So I derived all the derivations. And I can tell you, you can just go through that. That's some wonderful playlist this is, where we covered all the theory, all the derivations, all the previous year questions, loads and loads of practice questions related to both GATE and ESC, and some specially designed practice questions for your practice. All this we had covered in Module 1, Elements of EMF Theory. These Elements of EMF Theory has two sections. One, static field theory. The second is time varying field theory. Under static field theory, We had covered electrostatics, and magnetostatics. Electrostatics, one second here, one second. Okay, in static field theory, we covered electrostatics and magnetostatics. Electrostatics and magnetostatics put together is called static field theory. And in this electrostatics and magnetostatics put together, we had covered Maxwell equations. We covered Maxwell equations. Maxwell equations for static fields. Under Maxwell equations for static fields, we derived equation number 1. Closed surface integral of d dot ds is equal to volume integral of rho v dv. This is called integral form of Maxwell's first equation. Del dot d is equal to rho v. Differential form of Maxwell's first equation. Source, Gauss law for electric fields. Second equation, closed loop integral of E dot dl is 0. Differential form del cross E is equal to 0. Implies curl of E is 0. Or E is irrotational. Or static electric field is conservative field. This is property of conservative nature of electric field. Third equation, these first two equations are from electrostatics. Third equation, closed loop integral of h dot dl is equal to surface integral of j dot ds. Differential form del cross h is equal to j. Source, Ampere's law. Fourth equation, closed surface integral of B dot ds is 0. Differential form del dot B is equal to 0. Source, non-existence of magnetic monopole. Also given by Gauss law for magnetic fields. Good morning, Prakash. These two equations are from magnetostatics. So this is the main concept. The heart of static field theory is nothing but deriving Maxwell equations that we have done. Of course, we had covered so many number of topics in these 50 hours, but this is the main concept. And if you want to go through the details, please go to the playlist. For detailed explanations of all this, you can please refer the playlist. And as a part of static field theory, some more important topics that we have covered. Poisson's and Laplace equations. We have derived Poisson's and Laplace equations in all the coordinate systems. And also we had seen the applications. Very, very interesting topic. We had seen the applications of Poisson's and Laplace equations, especially Laplace equations, in all the three coordinate systems. That is also some very interesting concept. Then we have seen the very important, only important things I am trying to write here. The very important boundary conditions. We have derived the four boundary conditions. Namely, ET1 is equal to ET2, implying the tangential component of electric field intensity is continuous across the boundary of discontinuity. dN1 is equal to dN2. The normal component of electric flux density is continuous across the boundary of discontinuity if and only if the surface charge density that is placed deliberately on the boundary is equal to 0. It is conditionally continuous. And HT2 minus ST1 is equal to K, or ST1 is equal to ST2. Tangential component of magnetic field intensity is continuous across the boundary of discontinuity if and only if the surface current K is equal to 0. Conditionally continuous. Bn1 is equal to Bn2. Normal component of magnetic flux density is continuous across the boundary of discontinuity. Also we had seen about capacitors and inductors. Some very good applications, repeatedly asked questions, repeatedly asked concepts, especially in capacitors. All the derivations regarding the capacitors, namely the parallel plate capacitor, the cylindrical capacitor, the spherical capacitor, the derivations. These are most important for ESC. The numericals, the most important for gate. We had covered them comprehensively in static field theory. The second part of it is time varying field theory. In time varying field theory, we derive Maxwell equations for time varying fields. But Maxwell equations for static fields and Maxwell equations for time varying fields look alike, because their equation 1 and equation 4 are same. These both are same. Only thing is there will be modification in equation 2 and equation 3. Equation 2 is modified by Faraday's law. Equation 3 is modified by Maxwell contribution. So these two topics mainly we have discussed under time varying field theory. Under time varying field theory, we discussed about Faraday's law. According to Faraday's law, closed loop integral of E dot dl is equal to surface integral of minus dou b by dou t dot ds. Integral form. Differential form del cross E is equal to minus dou b by dou t. The point to be remembered is del cross E is no more 0 here. That means what? Only static electric field is conservative, but not time varying electric field. Or in simple words, Only for static electric field the rotation is 0. Not for time varying electric field. In time varying electric field, if the rotation is 0, that cannot be part of a wave. And you can see in time varying fields, there is a definite relation between the electric field and the magnetic field, or spatial orientation of electric field and the time varying magnetic field. And the equation del cross E is equal to minus dou B by dou T says that the spatial orientation of electric field depends on the time varying magnetic field. This space orientation and the time changing relation must be there if it relates to a EM wave. In an EM wave, because a wave is defined as something which changes its phase with respect to both space and time. Therefore, there must be a definite relation between the spatial change of one field to the time varying change of another field. That is very clearly shown in Faraday's law, which later can be modified. This equation will be modified into wave equation or Helmholtz equation, through which we derive the concepts regarding EM wave propagation. Similarly, Maxwell contribution also called as inconsistency of Ampere's law. Which gives that closed loop integral of H dot dl is equal to surface integral of j plus jd dot ds. Differential form del cross H is equal to j plus jd, where j is conduction current density given by sigma E, jd is displacement current density given by dou d by dou t. Again you can see the spatial orientation of magnetic field depends on the time varying electric field. There is an interrelation. If you take these two equations, clearly you can see there is an interrelation. The interrelation is del cross E is equal to minus dou B by dou T. Spatial orientation of electric field depends on time varying magnetic field. Del cross H is equal to J plus JD. J is conduction current density, depends on the conductivity of material given by sigma E. And JD is displacement current density, depends on time varying electric field. And here you can see the spatial orientation of magnetic field depends on time varying electric field. That interrelation very clearly you can see from these two equations, which are combined to form Helmholtz equation. Helmholtz equations are del square E is equal to gamma square E, and del square H is equal to gamma square H. These are Helmholtz equations, solving which you will get, are also called as wave equations, solving which you will get the behavior of electric field and magnetic field as a part of EM wave. So these are nothing but a wave equation. So from where you are getting wave? From these equations, which are Maxwell equations for time varying fields. That's why this connectivity is very important. From static field you will have connectivity to time varying field. From time varying field you will have connectivity to EM waves. This connectivity is very, very important. Clear? So that's about module 1, where we have recorded 40 videos with 50 hours of recording. Will be useful for both EC and electrical. For electrical it is complete syllabi. So just go through it, that must be enough. This playlist must be more than enough for your preparation for GATE and ESC. Regarding module 1, complete syllabus for electrical, a part of syllabus for EC. Any doubts? Okay. So there you can get all the module 1 and module 2. Is EM wave propagation. Now, from Maxwell equations for time varying fields, you will get Helmholtz equations. Helmholtz equation are nothing but wave equations, will tell you how the wave propagates. So, in this, already we have recorded 8 videos, 18 hours of lecture, and some more 7 hours of lecture is left out. Total will plan 25 hours of lecture for module 2. Again, module 2 maximum you will get 8 or 9 hours of lecture in any YouTube channel. Against that, we are recording 25 hours. That means we cover comprehensively. The time is the factor which is telling you that we are here to cover the syllabi comprehensively. In module 2, we had seen once Maxwell equation for time varying fields are derived, we had seen how EM wave propagates. EM wave propagation in free space. Free space means conductivity sigma is 0, epsilon r is 1, and mu r is 1. And in this we are derived, we explained how EM wave propagates in free space. Then we are derived the value of alpha attenuation in free space, beta, phase shift constant, velocity, and eta. For detailed explanation about EM wave propagation in free space, please go through this particular playlist. Refer this playlist. Next. Gone through EM wave propagation in materials with finite conductivity. That means sigma not equal to 0, epsilon r greater than 1, mu r greater than 1. And we have derived the general expression for alpha and beta. We have derived velocity, eta intrinsic impedance, and derived about loss tangent, or a dissipation factor given by tan phi sigma by omega epsilon, where phi is 2 times of theta n and theta n is angle of intrinsic impedance. See how closely they are related here. If you want to understand the subject better, these relations, this link you need to understand carefully. Clear? Is that clear? Then we have seen EM wave propagation in good conductors. Sigma is far greater than omega epsilon. Sigma by omega epsilon is far greater than 1. Sigma by omega epsilon is greater than 100. Good conductor case, in which we have derived the expression for alpha, beta, velocity and eta. Along with that, we have also derived concept of penetration depth or skin depth and surface resistance. In terms of skin depth, we got it as 1 by sigma delta. All this we have derived EM wave propagation in good conductors. Then we have seen EM wave propagation in good dielectrics. That's the case where sigma far less than omega epsilon, sigma by omega epsilon far less than 1, sigma by omega epsilon less than 1 by 100. There we derived the expressions for alpha, beta, velocity and eta. These are some wonderful derivations we have done along with the previous year questions and practice questions that will be useful for both GATE and engineering services. So this topic we have discussed in detail. Then we have seen EM wave propagation in perfect dielectrics. For detailed explanation about this wonderful EM wave propagation concepts, please go through this particular playlist. EM wave propagation in perfect dielectrics, sigma is 0, epsilon are greater than 1 and mu are greater than 1. Here also we derived the expression for alpha, beta, velocity and eta. The first 5 topics discuss about EM wave propagation in different medium. And also we have done comparison of this EM wave propagation through different mediums. All the different parameters we compared and we have tabulated them. Please go through that most important table which gives you analysis of how these parameters like alpha, beta, velocity, eta are changing from medium to medium. One detailed explanation. Indeed, a very detailed explanation about this comparison of EM wave propagation like never before we have done on this particular playlist. Please go through it. Surely, it is very difficult or hard to find such a wonderful table in which all the analysis of EM wave propagation is done. So, just go through it. And also we had covered pointing theorem here. Pointing theorem talks about the power associated with an EM wave. Pointing theorem talks about the power associated with an EM wave. So we have derived the pointing theorem. Theory, derivation is done. What is left out is we need to solve the previous year questions plus lot of practice questions. These two are pending in this topic, pointing theorem. Other than this, we have two more topics here. One, the very interesting wave polarization. Two, reflection and refraction of plane waves. Reflection and refraction of plane waves. These two topics are pending. We'll try to cover these two topics in this week. For these topics to cover, it will approximately take 7 hours. Making this particular module of 25 hours. So if this is completed, then module 1 and module 2 itself will be for 75 hours. That's the reason I say that you cannot find more in detailed explanation about EMFT other than this particular channel. Okay, in module 3, module 3 is about transmission lines. We need to cover this. Module 4 is about waveguides. Both these we need to complete. I'll start both of them parallelly. Both these modules I'll start parallelly. Then the last module, module 5. Which is antennas and optical fiber communication. In which optical fiber communication I'll do separate playlist. And for antennas, already designed a playlist. The name Antennas Mahamarathon series, in which already we have released 18 videos with 38 hours of content. So in module 1, we released 40 videos, 50 hours, fully completed. Module 2, 8 videos and 18 hours. 3 and 4 not done. Module 5, 18 videos and 38 hours. Total 106 hours of teaching is already done on EMFT. And I'm planning for 114 more hours, which will make 220 hours of course. Almost like some of the institutes give complete gate coaching in 200 hours. We teach only EMFT for 220 hours. That's the difference. This is where you can rely on Gate Conqueror channel. Got it? Give me 1 second here. 1 second. Just give me 1 second. Okay. Is that clear? 1 second. 1 second. Yeah. Just give me one moment. Fine. Okay. So in antennas Mahamarathon series, module 5, is about antennas and wave propagation. In module 5, we covered through antennas Mahamarathon series. In antennas Mahamarathon series, we covered basic terminology of antenna, current distribution in antennas, radiation mechanism of antennas. Again, for antennas, not more than 6 to 8 hours of recording you will get, or lecture you will get in any YouTube channel. Against that, we got already 38 hours of lecture on antennas. This will be useful for both GATE and ESC. Because for ESC you will also have wave propagation. We have seen radiation mechanism of antennas. This is a truly wonderful concept, radiation mechanism of antennas. Each and every EC engineer must know about this. Radiation mechanism of antenna is really truly wonderful concept which I discussed in detail. We have seen radiation mechanism of antennas by single wire, two wire, and dipole antenna. We have seen radiation mechanism by this. Just go through the playlist here. It's a wonderful concept. Then we discussed about radiation pattern of antenna. Radiation pattern is a diagrammatical representation of radiation of an antenna measured in the far field region. So under radiation pattern of antenna, we have discussed the terms like main lobe, major lobe, or the front lobe, minor lobes, side lobes, back lobes, front to back ratio, nulls, first nulls, beam width between first nulls, and half power beam width are the main concepts. And this we also discussed regarding side lobes. We also discussed something like SLR, side lobe ratio, are also called as side lobe level. A side lobe level of how much dB is treated to be excellent here? Can anyone recall and tell me? A side lobe ratio or side lobe level of how many dB is treated to be excellent? Side lobe ratio or side lobe level of how many dB is treated to be excellent here? Minus 20 dB. Again, what is the significance of minus 20 dB if you want? At minus 20 dB the power will become 1 by 100. At minus 20 dB, how the power will become 1 by 100? If you want to know, please go through the playlist. In detailed explanation for the same is given there. Then we had seen radiation parameters of antenna. Under radiation parameters of antenna, discuss topics like simple gain, directive gain, gain where losses are not considered, power gain, practical gain where losses are considered, directivity, antenna efficiency, radiation resistance, very important topic. Especially for numericals, radiation resistance concept is very important. Radiation resistance, beam area or beam solid angle, elementary solid angle, elementary solid angle, radiation intensity, effective aperture area, then we derived effectiveness ratio alpha, scattering ratio beta, absorption ratio gamma, and other concepts like antenna temperature, and its relation with noise figure. And also we had seen effective length concept, LE is given by open circuit voltage by electric field. This we had discussed in the first half. where actual VHF, UHF, SHF antennas will come into picture. These are the foundation for understanding antennas. And I can proudly tell you one thing, dear, you cannot get more detailed explanation than this on antennas. This is a complete package on antennas. If you carefully observe these videos, this particular concept must be more than enough for you people. Because max to max 8 hours is the max thing I had seen in any channel about antennas. But already we recorded 38 hours on antennas. You can see just almost what we are planning for EMFT, 106 hours which we are completed, is far more ahead than all the other people. And once we complete it, it will become 220 hours. And I had seen many of the people completing the GATE course in 200 hours. So we take only 220 hours only on EMFT. That's the speciality of our GATE Conqueror channel. That's the speciality of Unacademy. Try to understand this difference. That is why I am trying to highlight. Because until and unless I tell you, the new students who are joining now, they should know what is available on our channel. Then, after this basic work, we discussed in detail about 7 sisters. Seven sisters are nothing but like seven sister states. And 7 sisters is the name coined by me. So generally, when someone hear about 7 sisters, they'll say, what is the 7 sister antennas? I coined them. I figured out that 7 important antennas are there, which I put together. I call it as 7 sisters. So again, you can never find this detailed explanation about 7 sisters on any channel. In detailed explanation about the 7 sisters, the theory, the construction, the design factors, previous year questions and practice questions on each antenna were done in detail. This is also wonderful concepts put together under 7 sisters. The 7 important antennas. Started with folded dipole antenna, which offers very high input impedance, used as driven element in Yagi-Uda antenna. There it goes, a folded dipole antenna. See here. This is the folded dipole antenna. This one is a folded dipole antenna. Second, Yagi-Uda antenna. The very famous Yagi-Uda antenna, previously which was used for receiving TV signals, which is a high gain antenna, or a super gain antenna or super directive antenna, which gives you gain of 40 dB, unbelievable 40 dB, which is a parasitic array, which is an example of parasitic array containing the driven element, director and the reflector, and mostly the driven element that is used is a folded dipole. let me show you. A diagram regarding the same. This is an example of Yagi-Uda. Practical example of Yagi-Uda antenna. Folded dipole, directors and reflector. Horizontal rod holding them, clamps to hold them. Vertical rod, clamp to hold them. This antenna you might have seen. Previously used for receiving TV signals, now replaced by dish antennas. Clear? We discussed on this. We discussed on helical antenna. Helical antenna is mainly used for generating circularly polarized waves. Used for circular polarization. Can be operated in two modes, mainly normal mode, where n into L, n is number of turns, L is length on each turn, is far less than lambda, very small antenna, or can be operated in axial mode. Huge antenna, circumference is approximately equal to lambda, or diameter is approximately equal to lambda by 3. Then you call this as in that the antenna is in axial mode. In normal mode, the main application is we use it in Wi-Fi router. We use it in Wi-Fi router. In axial mode, we use it in space communication and can be used in satellite communications. That's about the helical antenna. This is used in the Wi-Fi router, you can see here. Inside it, there are delicate helical antennas. And the outer one which is covering this antenna is called a radome, hard dielectric structure which protects the antenna. And some very huge antennas like this are used in space propagation. Examples of your helical antennas. This is normal mode and this is axial mode. Clear, everyone? Is that clear? That's the third antenna, helical antenna. Fourth one, microstrip array antenna, which is used in antennas which can be designed compatible to IC technology, used in our cell phones, where you need the antenna to be compatible, to be fit on a board, or compatible with IC technology. One such very important antenna is a microstrip array antenna. Operates at microwave frequencies. At lower frequencies, you need larger size antennas, which is practically not possible. So let's see, microstrip array antenna. compatible with IC technology. It looks like this. See here, like this. These are the practical antennas. You can see here. This is about microstrip array antenna. And we have seen horn antennas. Standard antenna at high frequency used as feeder for parabolic reflector and lens antennas. It looks like this. Horn antenna. Practical horn antenna. Types of horn antenna, which are pyramidal horn antenna and conical horn antenna. Extension of circular waveguide gives you conical horn. Extension of rectangular waveguide gives you pyramidal horn. And now this is very closely related to again module 4, waveguides. So there is some interlink between these topics here. Okay, sorry. Yeah. Is that clear? Just give me 1 second here. Just one moment. Just just 1 second here, 1 second. I need to on the UPS. 1 second, okay? Can you give me 1 second? Just give me 1 second, I'll try to on the UPS, okay? 1 second, friends. Well, sorry, I'm back now. Uh, Video audio clear? Video audio clear? Please confirm. There was a power issue. I need to on the the power backup for that. Okay, fine. So where we are? We are into horn antennas, am I right? Yeah. So these are the horn antennas. These are the horn antennas. Next, the sixth sister is a parabolic reflector antenna, or also called as dish antenna, which are exclusively used today in TV reception, and where the primary antenna for that is the horn antenna, the torch-like structure that feeds the parabolic reflector or the dish is a horn antenna, which acts as the primary antenna, and the dish acts as a secondary antenna, which converts spherical wavefront into parallel wavefront. For in detailed explanation of this, please go through the antennas Mahamarathon series. Okay, and the last of the sisters, which is lens antenna. So we have covered these 7 antennas in detail in the name of 7 sisters, and also comprehensively we have covered antenna arrays. We covered antenna arrays. One second here. Fine. Good. Antenna arrays. An array is a structure where a group of radiators are put together in a proper way, geometrically and electrically, such that its effective radiation pattern increases. It's called antenna array, and the minimum number of elements that are required to form an array are 2. So we discussed about 2 element arrays. 5 different cases will be there. We have done the case study. Please go through the antennas Mahamarathon series. I don't want to waste time here. Please go through the antenna Mahamarathon series for in detailed explanation about these 5 cases. Then we have seen n element array. And especially we have discussed about, in n element case we have discussed about 2 standard cases, broadside array and end-fire array case. And we have seen special arrays, like Hansen and Woodyard array, also called as end-fire array with increased directivity. Here instead of maintaining alpha as minus beta d, we maintain minus beta d minus pi by n, where n is number of elements in the array. By doing so, we can increase the directivity by 78.9% of that of compared to end-fire array. Clear? That's a special array. One more array that we have discussed is binomial array. Binomial array, especially used to suppress the side lobes. Strong side lobes are called as grating lobes, which can be suppressed very easily by using binomial arrays, used in applications like radar. And binomial array is simply nothing but broadside array, which is fed with non-uniform amplitude of current. Broadside array with non-uniform amplitude of current. Clear? So that we have discussed about binomial array. Here side lobes is completely suppressed, but the only problem is we need to compromise on directivity, which decreases, or beam area, which increases. Proposed by Johnstone, and the amplitudes of current follows the coefficients of binomial series, and thereby the great Johnstone has given this name as binomial arrays. So these are the special kinds of arrays we have discussed. So comprehensively I can say we discussed everything about antenna arrays. So wonderful topic this is. In detail we have discussed about antenna arrays. And other than the seven sisters, we had also discussed about the resonant and non-resonant antennas. Under resonant antennas, we have discussed about monopole and dipole. And non-resonant, we have discussed about V antennas, inverted V antennas, and rhombic antennas. This is also a very special topic, very rarely found in any playlist. Seven sister concept also very rarely you can observe or you can find on YouTube. So we discussed about resonant and non-resonant antennas, and one more very rare topic we have discussed, which is antenna measurements. And antenna measurements we have discussed about radiation pattern measurement. Let's see the concept of basic setup required for radiation pattern measurement. Basic setup required for radiation pattern measurement. Distance requirement. And uniform illumination requirement. And we have seen the concepts like measurement of gain and directivity. Under measurement of gain, it's in three antennas method. It's also called as first method. And we have seen measurement of gain of two identical antennas. Two identical standard antennas. It is also called as second method. In measurement of directivity, as directivity term involves double integral, directivity defined as phi max by phi AB, maximum radiation intensity to average radiation intensity defined as WR by 4 pi. This 4 pi times of phi max into WR is double integral of phi of d omega. D omega is the elementary solid angle given by sin theta, d theta, d phi. As a double integral is involved here, one with respect to phi, other with respect to theta is varying. So, general method is not sufficient. Either phi or theta needs to be kept constant. Cases where phi is kept constant and the directivity is evaluated is called orange slice method. Orange slice method. Where phi is kept constant and the change of radiation intensity is measured with respect to theta, and the other is conical cut method. But theta is kept constant and change of radiation intensity is measured with respect to phi. Remember, here phi is radiation intensity. Here phi is azimuthal angle. Don't get confused here, okay? This is azimuthal angle and this is radiation intensity. Here phi is constant means I am talking about azimuthal angle. Is it clear? So these topics were discussed in antennas. But as I told you, this antennas Mahamarathon series was intended to cover antennas and wave propagation. Under wave propagation, we are covered principal modes of propagation, which are ground wave propagation, allows frequencies up to 2 MHz, sky wave propagation, allows frequencies between 2 MHz to 30 MHz, that means most of the short waves. Therefore, it is also called as short wave propagation, as it uses ionosphere, it is also called as ionospheric propagation. Space wave propagation, where we use frequencies between 30 MHz to 300 MHz. These are principal modes of propagation. For in detail explanation about the principal modes of propagation, please go through Antennas Mahamarathon series. And in special modes of propagation, we have seen scatter propagation. Under scatter propagation, we have seen tropospheric scatter propagation. The propagation happens between 100 megahertz to 10 gigahertz, and the major reason for the formation or for the tropospheric scatter propagation is the formation of the turbulence region, where masses or eddies of different dielectric constant move with random velocities in random directions, forming the disturbance region called as turbulence region, due to which scatter happens and the propagation happens much beyond the horizon. And the main scatter that is responsible for the propagation is the forward scatter, therefore it is also called as forward scatter propagation. And the other is ionospheric scatter propagation. Ionospheric scatter propagation. Propagation happens between 25 megahertz and 60 megahertz, lower part of VHF. This is mainly because of the formation of sporadic E layer. The sporadic E layer is a region that is formed very close to the E region, 5 to 10 kilometers away, with very high ionic density, formed due to infiltration of top layers. Second one is a reductive propagation. Propagation that is happening because of the formation of duct in the coastal region or above the ocean, where the humidity, water vapor conditions are extremely different, forming inversion layers. And an inversion layer is a concept where temperature increases with height instead of decreasing with height at the rate of 6.5 degrees Celsius. That happens in the general tropospheric region. So because of the formation of these inversion layers, super refraction takes place between these inversion layers, or when the wave is propagating, the wave undergoes super refraction, and the wave is literally trapped in the duct, which acts as the leaky waveguide, and the propagation happens. Frequencies allows the frequencies between 300 megahertz to 30 gigahertz. Only about frequencies I am talking here. For detailed explanation, please go through Antenna's Mahamarathon series. So these are the 5 modes of propagation. 3 are principal modes of propagation, 2 are special modes of propagation. Clear? Other than this, it's in structure of atmosphere. And the structure of atmosphere we have seen structure of troposphere, and structure of ionosphere. Especially structure of ionosphere, very in detailed explanation we are given. Please go through the Antenna's Mahamarathon series for in detailed explanation. Then we have started and also derived the very important derivation for refractive index of ionosphere. Then we are seeing the mechanism of radio waves bending by ionosphere. In refractive index of ionosphere, we have derived the derivation for refractive index of ionosphere. Mu or n is equal to sin I by sin r is equal to under root of 1 minus 81 n by f square. And mechanism of radio waves bending by ionosphere says that the waves will bend only when the mu or n value is real, which happens only when f square is greater than 81 n or equal to 81 n. That's the condition for the waves to bend by the ionosphere. Very important concept again. We have seen the concept of virtual height. We got it as h prime is equal to ct by 2. It's in concept of critical frequency. Fc is 9 root nm. Nm is maximum ionic density. Fc is critical frequency given in megahertz. Nm is ionic density given in per meter cube. That's in maximum usable frequency. Which got it as FMEF is equal to Fc into secant I, which is called as secant law. From this, FMEF is always greater than Fc because secant value is never less than 1. And you got FMEF Fc into under root of 1 plus d by 2h whole square. Then we are seeing least usable frequency and the factors that determine the least usable frequency we had seen. And we had seen skip distance. Since skip distance, you got it as d skip is equal to 2h into under root of FMEF by Fc whole square minus 1. You can derive this from this. Skip distance is a distance which is neither covered by ground wave or space wave or sky wave. It's in optimum working frequency, which is 85% of maximum usable frequency. All this we have discussed here under this very important concept of refractive index of ionosphere. Other than this, we have seen ionospheric abnormalities. Under ionospheric abnormalities, we discussed about 10 different concepts which are responsible for disturbance in the ionosphere. Mainly we are discussed on sudden ionospheric disturbance, which is mainly because of gigantic emission of hydrogen from sun followed by X-rays forming the solar flares, and which are responsible for increasing the least usable frequency greater than the maximum usable frequency, resulting in complete blackout observed by two scientists, namely Mongol and Delinger. Therefore, it is also called as Mongol-Delinger effect. Second major cause is ionospheric storms, resulting in change in critical frequency, sunspot cycles. Because of change in radiation of the sun, the critical frequencies of the layers vary, and then the phenomena repeats every 11 years. A careful study of sunspot cycle is required for an engineer to operate or establish a communication system and maintain throughout the different seasons and different years. These three are the major thing. Other than that, we have seen many different things, like we had seen fading, types of fadings, we had seen Luxembourg effect and all this and all, many things, man-made noise and all, 10 different things we had seen. But these are the major. For detailed explanation, please go through Antenna's Mahamarathon series, dear. Other than this, let's say we have seen different the concept called fading, and we have seen path loss calculation, which path loss is given by 32.45 20 log to base 10, frequency in megahertz, 20 log to base 10, distance in kilometer. This we have seen. Then also we derived the very important range of space wave propagation and the most important expression for received electric field strength in space waves, which we derived as 88 root P HD HR by lambda D square volt per meter. The very important, the most important derivations, which will be useful for engineering services mains. So this comprehensively we have derived all these concepts there. So basically, module 1, we are having 50 hours of lecture ready. Module 2, small part is unfinished, I will finish this week. 18 hours is ready. In module 5, In module 5, 38 hours of lecture is ready. Total 106 hours is ready. I'll add up 114 hours more. Clear? We'll make it 220 hours course for EMFT. So dear, what I want to tell you is, you can rely on our channel Gate Conqueror, because we are here determined to complete the syllabi comprehensively for you people. Let me solve some questions on, because we are into the MCQ series. Let me solve some MCQs. Grating lobes. Grating lobes are strong dash lobes. Which lobes are called as grating lobes? As I told you in theory, grating lobes refers to strong side lobes. The strong side lobes refers to grating lobes. Option B is the answer. Clear? The next one. Very interesting question. The magnitude of side lobes decreases progressively with an envelope proportional to dash towards the other direction. There will be a derivation for this, dear. Very important one. The magnitude of side lobes decreases progressively in the other direction proportional to cot squared theta by 2. Option D is the answer. Is it clear? Next. This question very, very important here. Please make a note. Very, very important. It's a very, very important bit. The side lobes decreases progressively in the other direction proportional to cot square theta by 2. Travelling wave radiator. Again, one more very important question. Try to answer. Travelling wave radiator is dash polarized. Travelling wave radiator is dash polarized. I repeat it. Travelling wave radiator is dash polarized. What is the polarization of a travelling wave radiator? For a travelling wave radiator, try to answer. For a travelling wave radiator, what is the polarization? Very, very important question here. This is again repeatedly asked across different competitive exams. The polarization of travelling wave radiator, it is linearly polarized. It is linearly polarized. The option is the answer. In a travelling wave radiator, again one more very important question. All very important questions today in a line. In travelling wave radiator, E, electric field is always dash to the plane containing radiator and the radial vector to the observation point. Try to answer it here. I repeat the question again. In a travelling wave radiator, E, electric field is always dash to the plane containing the radiator and the radial vector. How it is? The electric field is always parallel to the radiator and the plane containing the radial vector to the observation point. Option is the answer. Fifth question. In V antennas, inclination angles and lengths are equal, then the antenna is said to be in a V antenna where the inclination angles called beta and the lengths called L, if they are equal, then this antenna is said to be symmetrical. Important question. Question number 5, option A is the answer. If gamma is the included angle and beta is the inclination angle, what do you mean by included angle and inclination angle? If this is the waveguide or if this is the feeder which is feeding your V antenna, these are the legs of the V antenna, then this angle is called as included angle. This is called as included angle given by gamma. This is included angle given by gamma. Now, once you feed this current, this antenna will radiate. This is the radiation. The V antenna is a non-resonant antenna terminated in its load. It's a non-resonant antenna for unidirectional pattern. Now this is a inclination angle. The angle between the radiator and the maximum radiation. This is beta, inclination angle. This is included angle. This is inclination angle. Now listen carefully. What is saying? If this gamma is equal to 2 times of beta, then what happens? Main lobe of radiation is along the bisecting angle of the antenna. Draw a bisector from here and draw a bisector from here. This is the bisecting angle. The main lobe is along the bisecting angle of the antenna. Main lobe of radiation splits into 2 lobes. Main lobe tilts upward from the plane of V antenna. Main lobe diminishes to 0. What happens? When gamma is equal to 2 times of beta, where gamma is the included angle, beta is the inclination angle as I explained here. When gamma is 2 times of beta, main lobe will be along the bisecting angle. Very, very, very important question. Remember here, there are 3 or 4 questions basing on this concept which are very, very important. Next, the same concept again. Now as you know what is gamma and what is beta. If gamma is the included angle and beta is the inclination angle, as I told you. Now if gamma is greater than 2 times of beta, what happens? When gamma is equal to 2 times of beta, main lobe is along the bisecting angle. So not this. Now if gamma is greater than 2 times of beta, what happens? The main lobe of radiation splits into 2 distinct lobes. Again, very, very important. Because this is concept oriented, only when you know that you can write. Question number 7, option B is the answer. Now again, if gamma is the included angle, beta is the inclination angle, you know gamma is equal to 2 times of beta, main lobe is along the bisecting angle. Gamma is greater than 2 times of beta, the main lobe splits into 2 lobes. Not this. Gamma is less than 2 times of beta, then the main lobe tilts upward like this, tilts upward to the plane of V antenna. Some tilt angle will be there like this. It will face towards the sky. Gamma is less than 2 times of beta. Next. If gamma is the included angle, beta is the inclination angle, in which case is suitable for ionospheric propagation. Ionospheric propagation means this Earth surface. Ionosphere is something which is between 50 to 400 kilometers above the Earth surface. This is ionosphere. For ionospheric propagation, if the V antenna is placed like this, for ionospheric propagation, there must be inclination angle, or the main lobe of radiation must face towards the sky. This will happen or it will maintain the inclination angle only when gamma is less than 2 times of beta. Because when gamma is equal to 2 times of beta, main lobe is along the bisecting angle. Gamma greater than 2 times of beta, main lobe is splitting into two lobes. When gamma is less than 2 times of beta, then it is facing with an inclination towards the sky, which is suitable for ionospheric propagation. Option D is the answer. Clear? Anyone? Any doubts? Yeah, please let me know. Last question for this class. When included angle, as you know what is included angle, which is gamma. This is not R, okay? Printing mistake. Gamma, okay? This is gamma, okay? When gamma is greater than 120 degrees, what happens? When gamma is less than 120 degrees, what happens? When gamma is greater than 120, it exhibits vertical polarization. When gamma is less than 120, it exhibits horizontal polarization. Question number 10, option B is the answer. Again, very, very important question. One more very, very important question here. Okay? Rest of the questions we will see in the next class. Unacademy offers 2 paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly tests, structured courses, unlimited access, rank into batches and crash courses. In Iconic, you'll get all these features of Plus subscription. Along with that, you get a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts within 1 hour, preparatory study material, personalized test analysis, study booster sessions, and study planner. Unacademy offers 2 paid platforms, as I told you, Plus subscription or Iconic subscription. Whether you're taking Plus subscription or Iconic subscription, I recommend you to go for a no cost EMI, where total cost will be divided by number of months without any extra cost. And moreover, if you are using our code, our team code KNR10, you'll not only get extra 10% off, but also you'll get the complete team support. This is the uniqueness of this wonderful code KNR10. Try to utilize this. Unlike other codes, only we get percentage off. In KNR10, you'll get the complete team support. from the Gate Conqueror channel. And these are the iconic subscription benefits where you get a personal coach which gives you 1:1 live mentoring, increasing your chance of getting a top rank. And with every 1 year subscription, we are giving away 6-month extension here. So there must be no breaks for your preparation. So accelerate your preparation using this. Use our code KNR10 to get extra 10% off and also complete team support. And if you are having any doubts in your preparation, subscription or latest offers, you can contact our counselor and this is the contact number for the same. And Unacademy introduced a feature called Ask a Doubt through which you can ask unlimited number of doubts. You can ask 3 doubts at a time. You can get the solution in preferred language. And also very easy to ask your doubt. Click, crop and submit. That's it. So we are here to clear your doubts dear. Please ask us doubts. The super combo offer going on with every 2-year subscription. We are giving away 1 year subscription free for campus placement and IT jobs. With every 1 year subscription, we are giving away 6-month subscription for campus placement and IT jobs. There's rank predictor going on. Just very easy to check your rank if you attempted GATE 2022. Just log in, go to GATE landing page, click on rank predictor banner, select your stream, select the session that you appeared, paste your URL, then your rank will be displayed. These are special class features where you have interactive live classes for the learners, poll for the learners, raise the hand option. You never miss a class when the notification is on. You can download the lecture notes when the class is done. You can access anytime and anywhere. We are introducing community where you never miss any update from your favorite educator. You can download session notes and practice material. You can share your feedback directly with the educators via polls. These are the new batches here. As you know, every week we start almost 7 to 8 new batches. These are the new batches. Where you get 2024. These are all started on March 2nd. Where you get 2024 for electrical explained in English. Ascent Gate 2024 for ECE explained bilingual. Ascent Gate 2024 for electrical explained bilingual. Evolve Gate 2023 for electrical explained bilingual. Spark Gate 2023 for electrical explained in English. And Where Gate 2024 for electrical explained in English. For all of which you can use KNR10, which gives you not only 10% off but also complete team support. We are here to support you people. Just remember this. Thank you all for joining. Let us meet in the evening class at 9 p.m. At 9 p.m. we'll meet for MCQ 9. We'll learn more questions from antennas. Till then, take care and have a good day.